All right, so we're going to be starting the semester off by reviewing some of the important concepts in chapter 4. So I have kind of a list of a couple things here, including one that's going to be a little bit new to us, but we'll go over it as though it's a new topic. So we have the triangle sum theorem. So that's going to be one that we use quite a bit. We're going to have triangles all over the place. So, basic idea, right? All of the interior angles of a triangle will add to be 180 degrees. Doesn't matter what kind of triangle it is, right triangle, acute triangle, whatever. They're always going to add up to 180. And triangles show up all over the place, so we'll definitely be making use of that. We'll take a look at some examples of that specifically in a little bit here. Understanding the triangle congruence shortcuts. So how can we show that two triangles are congruent with sort of limited information? So quick reminder of what those 5 shortcuts are. We have side, side, side. That means that 3 sides of one triangle are congruent to the corresponding sides of another triangle. And that gives us side, side, side congruence. Side angle side, that's when we have 2 congruent sides, right? So this side and this side are going to be congruent to the same sides in another triangle. And then the angle that is in between those 2 sides, SAS, the angle has to be the included angle in between the sides. Those are going to be congruent to each other as well. That gives us side angle, congruence. And then we have angle, side angle. Similar idea. We have 2 congruent angle pairs, so 2 angles in each triangle. And then the included sides, the sides that are in between those, are also congruent. Angle, angle, side, that's a slightly different, right? You'll notice the location of the S here. It's a non-included side. So we have those 2 angles, but then one of the sides, that's not the side that's not in between them, right? One of those 2 sides is congruent. And then finally, we have this special one, hypotenuse leg, which only works for right triangles. So hypotenuse leg is specific to right triangles, where the hypotenuse of one triangle is congruent to the hypotenuse of another, and then the legs are congruent as well. So that gives us congruent triangles, and that is different than all of these other ones. It doesn't apply in these other ways. All right, and then finally, this is our new idea here, special right triangles. So you'll see things, we have 2 types of special right triangles here. We have something that's called the 45, 45, 90 triangle. It's named that way because of the angle measurements. We have 2 45-degree angles and a 90-degree angle. And the sides are always going to follow this relationship. Our legs are going to be the A's in this case. They're going to be the same. And then our hypotenuse, which is going to be slightly longer, is A times the square root of 2. So there's that. And then we have the 30, 60, 90 triangle. So the 30, 60, 90, again, that's based on the angle measurements. We have a 30-degree angle, a 60-degree angle, and a 90-degree angle. And the legs are a little more complicated here, or the sides are a little more complicated here. The short leg is our A side, that's our base measurement. The longer leg is the square root of 3 times A. And then the hypotenuse, which is the longest side, is 2 times A. People often confuse these two. 2 is slightly bigger than the square root of 3, so it's still the longest. Square root of 3 is around 1.73, something like that. So 2 is a little bigger than that. Anyway, we'll take a look specifically. We'll take a look specifically about how to use these A's and root 2's and all that stuff to solve things in just a moment. Yeah. Anyway, I'll go ahead and stop part 1 there. That was kind of an introduction, and we will look at some examples together.